Alright guys, so let's go over average rate of change, okay? So first off, let's start off with the equation used to describe this, okay? So usually when you see average rate of change, you'll see delta y all over delta x, okay? And don't let this confuse you. This delta, all this means, it's a universal symbol for change in y, okay? So in other words, how are your y's changing, okay? So usually you could write this as y2 minus y1 over x2 minus x1, okay? So you could write it like that, or you could say it's the difference in your y's. So it's just the subtraction of any two y's that you have. So a lot of different times you could represent it as something else. So you could write it as your difference in y over your difference in x. Okay. And what I mean by that is just you're just subtracting points. Okay. So let's go over an example. Okay. So in the book or on the slides, if you guys see them, they actually write this a little differently, right? They'll write it as f of, I think, a, right, minus f of b all over a minus b. Okay? And this is the exact same thing. So pretty much our a is going to be our first x, and our b is going to be our second x. Okay? So whenever we plug in our x value into our function, this whole thing right here, so this whole thing evaluated at a is going to give us our y1, right? So we're plugging in our x1, this gives us our y1. So in fact up here we have a y1 and then a y2 right here, right? And the order doesn't matter, they could be called y1, y2, it's up to you guys. Just make sure it's consistent, okay? And down here you'll see that, well, we have our x's on the bottom, so it's still the same thing. We still have a y on top and a y on, two y's on top subtracting, and we have two x's on the bottom. But don't let that mess you up. It's exactly the same. So let's go over some examples. So let's say we had a function of x. Let's say they told us we had a function of x at x squared, okay? And they want us to find the average rate of change. So average rate of change between or from -2 to 1. Okay? So in other words, they want us to find the rate of change uh, when it's negative, when x is equal to -2. So we'll call it x1 to x2, which is 1. Okay? So we have two x values that they give us. So in order to use this equation, we pretty much need an x and a y, right? So pretty much they give us our x's, but now it's up to us to go and find out what our y's are, right? And remember when I told you, whenever we plug in an x value into our function, that gives us a y, right? So if we take one of these x values and plug it into this function, that should give us a y. So let's do that. So if we plug in f of -2 into our function, we end up getting -2 squared, which gives us +4, right? So this right here is going to be the y value that we need for our function, right? So we need two y values on top, two x values on the bottom. So this is how we're using it right there. Now let's do it for the other one. So this we'll call it, we'll call this one, since this was x1, we'll call this one y1, okay? Now if we plug in f of 1 in here, this will give us 1 squared, and this gives us 1. So this right here would be y2, okay? So now we have our two y values, we have our two x values, and now we can go ahead and plug them into our difference equation, right? So this ends up being, and we'll keep it however you guys want, just make sure you guys keep it the same. So we'll do the y2 minus y1 for now. So y2 minus y1 all over x2 minus x1. That gives us 1 minus 4 on top, so y2 minus y1 all over x2 minus negative 2. Okay? And so we get a negative 3 on top, right? And then down here, 1 minus a negative, well, this whole part just turns into a plus sign, right? So this turns into 1 plus 2, which ends up being 3, okay? And then when we simplify a little more, we see that 3 over 3 just gives us 1, so then this in fact gives us negative 1 in total, okay? And that's it. This is your average rate of change. In other words, you found the slope of a secant line, and I'll show you what that means right now. Okay, and in calculus you'll see this a little bit more, but pretty much we are finding the slope of a secant line, okay? So let's go ahead and graph this, just a rough sketch, just so you guys can see what I mean by a secant line. So if we graph this x squared, it's going to look kind of like this, okay? And let's graph our 2 points. So at negative 2, this should be approximately 4 right here. You know, I'll do some different color just so you guys kind of get an idea. So this will be our first point, right? At negative 2, it equals positive 4. That makes sense. And at 1, it should equal 1 as well, right? So right there. So now if you see, and let me see if I could use this ruler. How do I grab this thing? I don't know how to use my ruler, so I will not use it. Okay, so you guys can see that right here, pretty much, let me see if I could angle this right. Okay, let me see. Okay, so pretty much here, we, oh my gosh, harder than it looks. Okay, so here we pretty much have a line. Jesus. We have a line. Ugh, I almost got it. Well, we pretty much have a line that goes like that, right? What you find when you find the rate of change, you're finding the slope to that line that connects those 2 points, okay? So that's the reason things change. So if we were to find the average rate of change between 2 other points, so like let's say they told us from 1 to 3, so now we would have to be solving from this point to 1, 2, 3, probably like up there, right? So now we're trying to find the slope of this line right here. So it depends on what x values they give you. Your secant line slope will change because of that, okay? So that's pretty much what we're looking for in this case, okay? Let's go ahead and solve this real quick just to make sure you guys understand this. So let's plug in 1 into our function. So we get f of 1 is equal to, oops, it's of course equal to 1 like we saw up here, right? So it's just 1 squared, which equals 1. Now let's plug in 3. So it's going to be 3 squared, which is equal to 9. So now you can see our 2 y values right here. And we have our 2 x values from what they told us. So we plug in our function, so it would be 9 minus 1 all over 3 minus 1. Okay? And that should give us 8 over 2, which ends up giving us a positive 4. So you can see this actually makes sense with our lines, right? Since this line is a downward slope, it makes sense that it's a negative 1. Since this is an upward slope and it's a very steep upward slope, it makes sense that it's a positive 4. So that's pretty much all there is to it, okay? All right. Let me know if you have any questions on in the comments, all right, guys?